And welcome on stage, Mike. Thanks so much for coming. I suggest that we start by giving you a big applause. Stage is yours.
You should save that until I've actually said something. All right, thank you. I'm going to talk about... Sorry, is that working? You hear me okay? Yeah. I'm going to talk about some of the process we're going through at work to get rid of our old legacy monolith and move it into a Python Django architecture. Something we're very much in the early middle of. So who am I? If you recognise what that is, I know roughly how old you are. That's what I started coding on. I've had most roles over the years and spent a lot of time as a legacy coder, something we'll get to that in a bit. And these days I'm pretty much Python and Django. So I'm on Blue Sky and Mastodon. Technically still on Twitter, but haven't been on there for months. So this is our legacy system, the traditional big ball of, we'll say mud. That's a little unfair, and it's more really people's perception of the legacy system. It is big. It does an awful lot of stuff. It's been around since, I think, 92 on our site. So there's an awful lot of convoluted code weaving its way in and out. Does multiple different things. So there is a lot of code complexity in there. And on a very basic level, it kind of looks something like this. We've got a monolith in the middle. There's 1,000 other systems that it kind of integrates with in various interesting ways. Flat files, SOAPs, APIs, hundreds of users, most of them kind of customer care representatives or things for the company, but lots of business people as well. And we have the database, which is not a relational database management system. It's essentially a load of flat files. So that's what we've been working with. A little bit more complicated than that. So that's essentially what we've been working with for many, many years. And a lot of these systems that we integrate with they're also dinosaurs, and probably will stay that way for a lot longer because they work. Some of them are really small. Some of them probably don't have anyone actually actively maintaining them because that person left 15 years ago, but you know, I think you all know how that is. So this discussion's been ongoing for many, many years. But the cons of the current system, the code is complex, different areas, very heavily tied together. The legacy language that it's written in, I won't go into that here, ask me later if you're interested. It's dying. There are very few consultants available for it. So it's hard to get hold of people. In fact, I think we've got most of them. And recently the licensing costs shot through the roof, largely because the company that owns it knows that it's dying and are trying to squeeze the last few dollars out of it. However, there are an awful lot of pros with it as well. It is very quick to develop in, quicker than any other of their in-house systems, despite the fact that it's probably larger than any of the other in-house systems. The database, the flat file one I was talking about, it's an ISOM-based database, CISOM to be specific. It's very, very quick for both read and write. Obviously, it's not relational, as I said. You've got to maintain the relationships yourself. And because it's been around for over 30 years, most things are solved problems. An awful lot of new business demands that come along can be met with, configuration and minor tweaks here and there. I don't know why I put that last one into prose. Yeah, that's not really a pro. It can't really be moved into that. Yeah, maybe, but that's not something I'd want to attempt. So, what were the options here? They want to swap it out for many reasons. So the options are do nothing, which should always be an option. It should always be the first option. Do we really actually want to do this, to do anything here, or are we okay as it is? Do we build a new monolith, or do we start looking at a distributed architecture with services and blah, blah, blah? So, excuse me. So the do nothing option, yeah. I mentioned there aren't many consultants left for this language. Most of them are kind of around my age, so in the next 5 to 10 years, people are looking at retirement and dropping out of the team, and that would leave them in a bit of a bind. And the huge support costs I mentioned earlier have led to us going out of support with the language itself, which isn't a problem from a development point of view. Isn't really a problem for the team, because, like I say, most things are solved problems, and we can sort things out ourselves if we need to. But enterprise companies do not like being out of support. They like to have that box ticked. So this wasn't an option, and we did kind of know that, because they've tried to swap this out 3 or 4 times over the years, and it hasn't really gone very well. So option 2, build a new monolith in a new stack. It doesn't solve the problem of code complexity. That would all still be there. We've got all of that stuff. It doesn't enforce the separation of concerns. We could have gone the modular monolith route, built the monolith, separated everything into smaller apps, and tried to enforce that. But the risk of leaking across the boundaries there and just ending up with the same big ball of mud in a different language was very real, I think. So, more to the point, it would still be a single team, probably maintaining the single system there. And I'd say this is a huge system. It's billing, invoicing, customer care, general ledger, inventory stuff, and dozens of other things. So all things that don't necessarily, normally hang together. So not an impossible idea, but perhaps not the ideal one from an organisational point of view. So the third one was build a more distributed architecture. The main benefit of that being that we could have multiple teams with smaller areas of responsibility, more easily manageable systems. If any of those ones needed swapping out in the future for something, that will be a lot easier to do, rather than having to deal with this massive legacy monolith again a second time in 10, 15 years. But moving to services or microservices, you're swapping code complexity for architectural complexity. The complexity doesn't disappear, it just moves into a different area. And microservices themselves should not be seen as a solution to system complexity in any way. They're a solution to organizational complexity. They make it easier to manage things in teams, smaller teams, more focused teams. But this was a preferred option. And going into the analysis, we did kind of know this was a preferred option as well. This was largely what was talked about from the beginning, but this is the route that we're going, and probably the route most people would have expected from the start. So, So the proposed stack, pretty standard for this room, probably Python, Django, Postgres, Redis, Rabbit, Celery. Initially, we're talking about deploying everything onto the same server as the current Monolith, because that was our server. But with making sure we keep one eye on what we can deploy to AWS, they're very much on a cloud transformation journey at this point. So things are being slowly moved into the cloud at work. But starting this new project straight in the cloud wasn't quite on the cards there. So initial deployments all to the same server, which isn't a problem. It's a huge server. So and we're talking about not so much microservices, but sort of macro services, to coin a new phrase. 8 to 10, I think we might be on 11 or 12 actually at this point, that reflect kind of the core functionality of the legacy system there. So we're talking 10, 11 smaller monoliths essentially, each running as their own service. More would be breaking up into too many, creating too many future teams, and making it a little bit pointless, adding unnecessary complexity to the architecture and all the communication and everything. So we thought this was a good goal, and manageable from an organizational point of view. And event-driven communication via using RabbitMQ as a message broker. How am I doing for time? Okay, so what did we start with on the knowledge base? We had all the domain knowledge and experience there, because these people been working with this legacy system for a long time. Little to no Python or Django experience, and very little experience around distributed architecture within the team. That is, there is some within the company, but not so much within the team, because it's tied to this existing legacy monolith. So at the beginning, excuse me, velocity was prioritized, and we started building to get a proof of concept out. Just to show that we could actually deliver something. Initial functionality was all built around Django admin. If you've seen some red flags, I understand that. But the idea being to make as few changes as possible to the existing monolith, because the goal is obviously to decommission it. Something we're still not sure if we'll actually do long term, if it will ever fully go away. We're not sure yet. And we've been sharing databases to a certain extent, to avoid some certain bits of architectural complexity and speed up the development. And that kind of worked for a while. A little later into the process, it's been going for about, what have we been doing now for 2.5 to 3 years, something, I think. So we got a bit more knowledge in the team now. We've got a couple of new Python Django resources on board, including me. Some of the existing team members have had training. A lot of the existing legacy coders are still very much used to some more procedural-based code. OO concepts can be a little confusing sometimes, just because they're not used to it. So there's a lot of reliance on reading across databases, and I'm also talking about to the legacy database here. We've got drivers in to read some data from there that we haven't yet migrated into the new things. That's the less problematic part, to be honest. Everything's still being done via Django admin at this point. This isn't now, this is a little while back, with no real front end other than sort of login stuff and things. And we don't have tests at this point, because velocity, prioritizing velocity kind of, precludes writing tests because tests take time. So next step. I'm hoping you learn from what we did wrong as well as what we did right here, just to be clear. So next step, okay, what patterns are we looking at here? So what we've done is we've introduced domain models for the core information concepts, and here we're getting into some domain-driven design stuff. So if you took a photo of Joseph's slide earlier when he's talking about some of this stuff, now it's time to take it out and look at it sneakily. So we've created domain models for the core information concepts. Ours are just data classes for the domain models. We're not using Pydantic, just because that would have been another new thing to introduce to the team, I think. And the data classes stuff that we've got working just fine. I don't see any issues with that. So we're also using this service repository pattern here. The repositories are mostly a wrapper around the Django ORM stuff, but they should allow us to also put some more complex SQL stuff in there later if we need to, and hide some of the slightly weirder things that might be going on with these cross-database reads until we can factor that stuff out later on. So at least that's all self-contained in one place. And the services, as Joseph mentioned, that they're largely the business logic side of things there. So we're using Celery for asynchronous tasks, and also integrating with the RabbitMQ stuff, and introducing PubSub for some communication between the services. Do I need to skip a couple of slides? Possibly. Very quickly, your code would look something like this. You'd create a domain object, you'd get your service, you'd call a method on the service which handles business logic. You'd see if there were any errors for that, and you'd handle them. So your main code will just be, and if you know the reference for that, you probably know what the ZX81 was as well. And you're probably British, actually, in fairness. All right, so this is kind of what the current architecture looks like. We've got the monolith over there, we've got the Postgres database there, we've got our new services marked with a little snake, old ones with a dinosaur, all that sort of stuff. So everything's reading Postgres, we've got some APIs coming in, but we've also got some legacy database reads going on from the services. Yeah, it's not ideal. But it is working at this point. So the next step is introducing the PubSub architecture. So we get RabbitMQ in place. We use the outbox pattern at this point. So we put messages into a specific table, and we've got a worker that just picks them up out the table and shoves and pushes them to RabbitMQ, to a RabbitMQ exchange. We got PubSub worker, which is subscribing to in each service. This is only in one service at this point. We're trying to roll it out to the others now. So we've got PubSub worker, or more than one probably, which will subscribe to various queues in RabbitMQ that it needs. All integrated with Celery. Celery is calling in some places into APIs into the legacy database. We've still got the legacy database reads going on. We've still got some Postgres sharing going on, and we haven't done anything with any of this stuff down here. final goal looks a little bit more like this, which is we've still got our pub sub stuff with all the services on the left-hand side, but now we've very much got this kind of separation. We've done away with these this database sharing and the legacy reads, and we've kind of wrapped the legacy system in our own broker service, which allows the legacy system to throw things into an outbox and sort of create their own and actually interact with RabbitMQ and be part of this pub sub architecture, something it can't do natively. So we're having to write our own broker for that, to handle that stuff. That will also, the broker, it's also intended that will sort of act as an API gateway a little bit into the legacy system, which will also allow us better to control some of these incoming APIs and perhaps apply things like the strangler pattern later on to start moving things around when we need to, because then we can redirect stuff a little bit better. And of course, that's actually the goal. We don't want all that stuff still communicating directly with the legacy system. We want that coming in, calling the APIs or integrating with RabbitMQ. So all that stuff needs to move to one of those two other things on the left, but that's probably a lot further down the line. And they're not systems I'm dealing with, so I'm just sort of going la 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 for that. So the biggest risk of this, and this is very subjectively, in my opinion, it's not something everyone agrees with, but I think the biggest risk that I see is that we partially deliver the new architecture. We lack some of these service boundaries that are sitting in place, but it's all deemed good enough by the business, who see everything hanging together and actually working without really seeing what's going on underneath. Which means what we've ended up doing is kind of extending the existing monolith, so it's now exponentially more complicated and now includes Python, Django, RabbitMQ, Celery, Redis, lots of other things, which is, not ideal. We still have all, if that happens, we still have all the problems from the earlier slide about licensing, available consultants, all the other stuff. So all the organizational problems would still be there, but it depends a little bit on how much we actually get out and into the new stuff. So for anyone going through this, some thoughts about how to sort of maximize your chances of success if you are doing it. Get the buy-in. Don't try and do this sort of part-time with a group of people that know the business side well, but we suffer a little bit from people getting pulled off the new stuff to go and work on the legacy system all the time, because obviously, again, not that many consultants available with that knowledge. So there's this constant pull to take resources off. So make sure the buy-in is there. A proof of concept is good, but it does need to prove something. And once you've proved that, move on. And make sure you've got these dedicated resources. As I say, we do suffer a little bit from that one. I'm building a temporary solution with, quote unquote, bad architecture. Again, not everyone agrees with my definition of bad here when I'm discussing this, but make sure that you're planning in the next step to actually clean this up. Yes, we're doing this temporarily. Yes, it will be like that for 6 months, but then this is happening. We're getting rid of it, and it's an intermediate step to get to the end goal. Do it sooner rather than later, otherwise it becomes part of the processes and it's a lot harder to remove. So, and do establish areas of responsibility with other internal systems. Who's responsible for for what, for which APIs, and where they're being called and communicated. So on the resource front, as I mentioned, we didn't really have the Python Django resources at the beginning. Find out who wants to learn the new tech and who doesn't. Some people are very keen on doing that. Some people are less keen on doing that. There's little point in having the less keen ones do it, because they've got all the business knowledge. Use them for the business knowledge in that case. So and try and make sure that you're a little bit in line with Raffaella's talk earlier. Try and sort of make sure people have got mentors or someone to help and guide them through things as they're doing sort of foundational changes, if they're still new to a lot of this stuff. So a little bit further reading. Yeah, more for time. If you've not seen these ones before, definitely worth doing. Both the Sam Newman books and the Cosmic Python one there have been very helpful. There's a few domain-driven design ones as well, so which are quite good. But I think these are the main ones to think about. So, and I think that's it. Thank you.
Thank you.
Yeah.
So you referring back to the early days when this decision was made, can you remember some of the reasons why Django was chosen for this task?
Yeah, it was actually one of the devs on our team was pushing very hard for Django, because he'd started using it a little bit earlier and liked it. We got a proof of concept up and running, and yeah, they liked it. So the Python Django, and Python was an improved technology already at the company, which helped. So they've got a list of languages and tools and all sorts of things which you are allowed to use, and if it's not on the list, you have to try and get it approved. Python was already there, so that made life a bit easier. So yeah.
Is there a question here? There's a question there. Oh, and there, and oh, there, and there. Yes.
Thanks a lot for the talk. And you mentioned that you're still lacking a front end. What is it that you're sort of missing from the Django admin that cannot be built on top of the Django admin?
There's nothing that can't be built on the Django admin, I don't think, in that sense. But as we're trying to sort of refactor some of this stuff, having everything in the Django admin becomes very hard to build tests for. Yeah, we are starting with tests now, yes. Yeah, we have some tests. I've got the one I'm managing is up to about 60% coverage now on unit tests, and there's a couple of the other services I've got. They're writing some end-to-end tests for them at the moment. So that's positive. But yeah, the Django admin side, that makes it very hard to actually test properly, and also we are. Because we've still got a lot of integration going on with the old system here and things, it's that trying to pull other data into admin also becomes a little bit complex. So we do have a little bit of front end at the moment. I did the first front end stuff other than the login side last year. So we've got a few front end screens on there, and we're using HTMX for because there isn't really any JavaScript knowledge, or not a lot of JavaScript knowledge in the team either. So, but HTMX seems to be working nicely with some caveats. But so we are moving on the front end stuff, I think. And yeah, a lot of it could be done in A lot of it could be done in admin, but having recently refactored some stuff out of admin, the hoops you had to jump through to get some of this working, it's not worth it. Do it in the front end to start with if you've got that possibility. Yeah.
Yeah, we had a lot more questions. Let's be good with the time. Yeah.
Okay. Thank you so much for your talk. My question, you've partly answered it. I was going to ask whether you've done any automated testing, but I think it's handled now.
Yes, well, it's handled is a relative term, but yes, we are doing some now. They've also got Jenkins is their CI tool of choice at work. So one of our services is now hooked into Jenkins, so it will run both linting and automated test on the pull requests. So you can't merge to main unless they've passed. That's for the moment. That's only on one repository. Yeah.
Thanks for the talk, and that was a nice segue into my question, which is, you didn't mention any challenges around version management, development process, release management. Has there been, like a change there?
What do you mean a change from?
As in, are there differences to how the Dinosaur was built and
Oh,
developed?
yeah, absolutely. Yes, most definitely. That had very, very custom release processes, which really don't align with anything that we're doing with this stuff now. The release process we got at this point is fairly simple because we basically tag the main branch with a date-based release tag, and then we check out that tag in the production environment when we're doing it. So essentially, there are some challenges there because the repository definition for the legacy file system sometimes gets regenerated, and that's sitting in the repositories at the moment, which means Git technically looks out of sync. That's something that we need to change. So there are challenges with the release process. But at this point, we're keeping it as simple as possible. I anticipate it changing at some point the first time we have to start doing something with AWS. So, and at that point, I don't know if we'll be moving to Docker-based deployment or something else. They do have a Kubernetes cluster at work, so maybe we'll be using that. I don't know.
We don't have so much more time, so I think we have to just take one question and then how do we pick that one question? There were, I saw two hands before. We take the first hand then.
Yeah, my question is a really small one. Thank you for the great talk. And you mentioned that your team back in the days wasn't really deeply familiar with microservice concepts.
Yeah.
And my question is, how much time has passed since you first decided to change your architecture until you developed your first proof of concept, and how big the team was?
The proof of concept we had before we actually started writing anything the first time. I've worked at this place a few times, and I had a gap in the middle when I wasn't there, which is where they started things, and then I came back. But the proof of concept was there before we started building the main stuff, and that was very much just, here's a service, we're deploying it, and we didn't have any of the architectural complexity in place then. We didn't have PubSub, we didn't have any of that. I did the Rabbit stuff early last year for one of the services for that. So that was when Rabbit and Celery came in for things like that. So the architectural complexity and the true microservices architecture has only really started coming into play in the last sort of 12 months or so. 12, 15 months, something like that. If that answers your question, I'm not sure. Yeah.
Yeah, I'm sorry that we don't have time for any more questions, but you'll be around for more.
Yes.
I'm sure. Really nice diagrams on the slides, by the way.
Oh, thank you.
I hope Danny is here. Yeah, thank you so much.